guys, as promised, I'm going to do practice tests for you guys for the full Anatomy and Physiology 1 and 2 series. We're going to do it chapter by chapter, and the way that it'll work is I've come up with this series of practice questions. They're just taken from old exams of mine, and I'll work through each question literally just the way that I would do it if I were taking the exam. So hopefully you guys will learn some test-taking skills, learn how to kind of use the information that I've taught you and think logically, and then you'll be able to test yourself to make sure that you understand everything. Now, a couple of tips as you work through this. One is you should get to the point where you can read the question, right, and pause the video so you can think through it and come up with the answer yourself. And then you can press play and see if your reasoning was correct. Also, think about other questions that could be asked. Okay, so for chapter 2 here on chemistry, I have probably like 25 practice questions, but you could flip these around and ask them different ways or ask similar questions, and you guys cannot come up with probably about 100 practice questions. Okay, so think about all the different ways that the information could be asked, and that'll help you when it comes time for the test. Okay, so bear with me, let's kind of go through this and see how it goes. So, the first question here, which of the following is true of the subatomic particles? So before I even look at the answers, I'm going to think, okay, wait, what are the subatomic particles? The parts of an atom, right? So the proton, the neutron, and the electron. So let's look at what our choices are. Electrons have a positive charge. Electrons, remember, have a negative charge, so that's not right. Electrons are located in the dense nucleus of an atom? No. Remember, in the nucleus we have protons and neutrons. Electrons are orbiting out in the electron cloud. Neutrons have a negative charge. We said electrons have a negative charge. Remember, neutrons are neutral, no charge. Protons have a positive charge. Yes. Right? Protons are positive, neutrons are neutral, electrons are negative. So the answer to that one would be D. So for the next one. If an element has an atomic number of 8 and a mass number of 17, how many protons, neutrons, and electrons would a neutral atom have? Okay, so first of all, you have to know what the atomic number tells you, and then you have to know which particles, which of the subatomic particles go into the mass. Right, so right off the bat, the atomic number tells you how many protons, right? That never changes. That tells you how many protons you have. And then if the atom is neutral, if it has no overall charge, then remember the number of protons and electrons are the same, right? Because protons are positive, electrons are negative, so they have to have the same of each to cancel each other out. So that atomic number of 8 tells you that you have 8 protons and 8 electrons. So right off the bat, looking at my answers, A does not have 8 protons and electrons, so it's not that. B, no, not that. C, okay. C is a possibility, right, because it has 8 protons and 8 electrons. D, no. E, no. So right off the bat, we know that it's C. But let's just check the neutrons just to be safe. Remember, to find out how many neutrons we have, we take the mass number and subtract the number of protons, right? Because the mass is the number of protons plus neutrons. So 17 minus 8 protons is going to give us 9 neutrons. So C is correct. Okay, so the next one. The next one's talking about, it looks like, compounds, molecules, elements, and understanding which is which. So H2O, water, is an example of a, so H2O means we have 2 hydrogen and 1 oxygen. Okay, they're covalently bonded together. So we have 3 different atoms, right? And we have two elements present. We have hydrogen present and oxygen present. So without even looking at my answers, I know that that's a molecule because I have at least two atoms. I also know that it's a compound because I have at least two atoms and I have two different elements, right? I have hydrogen and I have oxygen present. Okay, so I know that it's both of those. A compound only? No, I just said it's a compound and a molecule. An element only? No. Remember, an element is a pure substance. So if it was just hydrogen, or just oxygen, or just carbon, it would be an element. But I have multiple elements. I have hydrogen and oxygen, so it's not just an element. A molecule only? No, I just said it was both. So the answer would be D, right? A compound and a molecule. It's not an element, okay, so not E. Now, if it was just, say, H2, right, two hydrogen together without the oxygen, remember that would be a molecule, but it would not be a compound because it's only one element that's present. All right, so one single unit of hydrogen, okay, so one little microscopic hydrogen is a blank of hydrogen. Again, you should be able to answer these without even looking at the choices. Okay, so cover that up, and I could say 1 unit of hydrogen is an atom of hydrogen. So let's see if that's a choice. Compound, no, that's multiple things. A subatomic particle, no, we saw that those are protons, neutrons, and electrons. A molecule, no, that would be multiple atom, right? There's my choice. And do that as you go through the exam. Look at the question and formulate your response or your answer in your head before you even look at the choices. Then when you look at the choices, if you see something that matches with your answer that you already thought of, you're just solidifying your response. If you don't see something that matches, well, then you've got to go kind of look through everything and analyze it. But hopefully you'll see the same exact thing that you already thought of, and you know that that's the answer you should jump on. Which of the following is true regarding chemical bonding? Again, before I look, chemical bonding is the way that we join multiple atoms together, right, to make something bigger. And this has to do with electrons, right? The electrons are how atoms join together. We said that they can share electrons, they can give electrons away or take electrons, but it all has to do with electrons, right? Specifically, electrons in the valence shell, the outermost shell. So knowing all of that, let's look at our choices. So true, which of the following is true regarding bonding? Atoms form bonds to get to the highest mass possible. We just said that it has to do with electrons, right? And electrons are tiny, they don't go into the mass, so that doesn't really make any sense to me. That doesn't stand out in my head as being correct. Atoms form bonds to fill their valence shell with electrons? Yes, we did say that that's true. Remember, atoms are happy or stable when their valence shell is full. So yes, I know that's true. I'm going to keep reading in case something else is also true. Atoms form bonds to attain stability by gaining neutrons. Neutrons have nothing to do with it, right? Neutrons go into the mass. When we talk about how much an atom weighs, or like a different isotope, a different version of an atom with a different weight, then we look at neutrons, but not for bonding. So no, not C. Atoms always try to get 8 electrons in their valence shell. First off, anytime you see always or never, be weary of it, right? There's frequently exceptions. So that's weird right off the bat. But look at this, always try to get 8 electrons in their valence shell. Remember, each of the shells holds a different number of electrons. So they always want to fill their valence shell. But what if their valence shell is the first energy shell? Remember, that first energy shell only holds 2 electrons. So if that's the case, they only want 2 electrons in their valence shell. Right? So we can't say that it's always 8. If it's the second or third shell, yeah, we want to put 8 in there, but not always. Because again, the first shell only holds 2 electrons, so that would not be true. And then B and D. No, D is not the answer, so it can't be B and D. So the answer to that one would be B. Speaking of isotopes, which of the following correctly describes an isotope? Again, don't look at the answers. An isotope is a different version of an element, right? So you can have different versions of hydrogen or different versions of carbon. And what's different about them is their weight, right? How much they weigh. Their weight is different because they can have a different number of neutrons, okay? Remember, the number of protons never changes. Electrons have to do with bonding. Neutrons have to do with different isotopes. Okay, so let's look at our choices. A, different versions of an element, each with a different number of protons. What did we just say? Protons never change. The number of protons doesn't change, or it's not that element. Anytime you see the number of protons changing, that is wrong. Different versions of an element, each with a different mass. That's correct, right? Different isotopes have different masses. Let's look at the rest of our choices. Different versions of an element, each with a different number of electrons. No, right? Electrons have to do with bonding, not with isotopes. Isotopes are different versions of an element, each with a different number of neutrons. Ding, 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 right? That's what we said. They have a different mass because they have a different number of neutrons. Okay, so the answer to that would be B and D are both correct. And when you guys take the test, at least in my class, you can write on your exams. So do that. Like as you go through, like reading A, the part of A that's wrong is just protons. So cross that off and make it right. Right, neutrons. Right, and then you know that A is wrong. When B is correct, put a check mark next to it. Right, that's good. And keep reading. C, cross it off. When you get to D, that's correct. Put a check mark. Okay, write all over this exam so that you don't make silly mistakes and mix up your answers. Okay, so now it looks like we're getting into bonds. What type of bond occurs between the slightly positive and slightly negative portions of polar molecules? So we talked about all different types of bonds, right? We talked about ionic bonds, we talked about different types of covalent bonds, we talked about hydrogen bonds. So this is talking about bonds between the slightly positive and slightly negative portions of polar molecules. So in this case, we don't have two atoms joining together. We have two big molecules that have a slight attraction. So water is a great example of a polar molecule. Remember, water has kind of positive areas and kind of negative areas, and opposites attract. So there's a slight attraction there between the kind of positive and kind of negative parts. Remember, we called that a hydrogen bond. So a hydrogen bond, yes, that's correct. Ionic bond? No, an ionic bond is a bond between ions. Okay, so remember that's when one atom takes electrons and the other atom loses electrons. So you've got something that's negatively charged and something that's positively charged, ions, and those are attracted to each other. Okay, so those are not slight positive and negative. An ionic bond has a full positive charge and a full negative charge. Covalent bonds, remember both of those are where we share pairs of electrons. Okay, so there's, you're attaching atoms together. You're not having an attraction between two molecules. A saturated bond, I just made that up. We can have saturated fatty acids, but there's no such thing as a saturated bond. So, more bonds. Okay? If one pair of electrons is equally shared between two atoms, what kind of bond occurs? Remember, when we're sharing pairs of electrons, those are covalent bonds. So a covalent bond can be polar or nonpolar. When the two electrons or the pair is shared evenly, So you have two atoms that are pulling equally on those electrons and sharing them nice and evenly. That's a non-polar covalent bond. A polar covalent bond, remember, is when you have two atoms that share unequally. So one big bad atom is keeping those electrons for most of the time, so that part of the molecule is negative, kind of negative. This guy over here doesn't really have the electrons very much, so he's kind of positive. That would be polar. So in this case, the electrons are shared equally, so that would be a non-polar covalent bond. Also, we are sharing one pair of electrons, so that's a single covalent bond. If we share two pairs, that's a double covalent bond. If we share three pairs, that's a triple covalent bond. So let's look at the choices. Single covalent bond, that's possible, right? It is sharing one pair of electrons, so it is a single covalent bond. That choice doesn't specify polar or non-polar, so it's correct as far as the detail that we have. Polar ionic bond, that's made up, it's nothing. Hydrogen bond, no, that's not sharing electrons. A polar covalent bond, no, this is not polar, right? We're sharing the electrons equally. Non-polar ionic bond, again, there's no such thing as a polar or non-polar ionic bonds. Ions have charges all the time. So the best answer in this case is A, right? This is a single covalent bond because we're sharing one pair of electrons. This is non-polar, but we don't have a choice. This is non-polar, so A is the most correct answer there. We'll get through a couple more on this video, and then I'll make another one. Okay, so speaking of ions, right? Speaking of atoms that have charges, we can have an ion with a positive charge or a negative charge. Okay, so let's look at this next question. A blank has a positive charge, a blank has a negative charge. Okay, so let's look at A. A cation has a positive charge and an anion has a negative charge. That makes sense, right? Remember when we write cation, it has a big T in the middle, okay, a big positive side. So cations are positive, anions are negative. So A is correct. B flips those, that is not correct. Strong acid, weak acid, strong base, weak base, that's not what we're referring to when we talked about cations and anions. And E, an electron acceptor has a positive charge, and electron donor has a negative charge? No. If that were flipped, if it were the opposite, that would be correct, right? Remember that an electron donor gives away negative charges, so it's positive. And an electron acceptor takes the negatives, so it's negative. So if these were flip-flopped, that would be correct. Okay, but like this, they're not. So the answer is A. A cation has a positive charge, right? And an anion has a negative charge. Which of the following reactions would we include in the body's catabolism? Again, before looking at the answers, let's think about catabolism, anabolism, and metabolism. All the chemical reactions that are occurring in your body, no matter what kind, all of them together, that's referred to as your metabolism. Then we can break that up into two different parts, anabolism and catabolism. Remember, anabolism with an A, those are all of the reactions where we're building up bigger molecules, right? I said to think about anabolic steroids. Anabolic steroids build up muscle, right? Anabolic, building up. So anytime we're combining things and building bigger molecules and compounds and proteins and carbs, anytime we're building things, those chemical reactions are included in the body's anabolism. Catabolism is the opposite. Catabolism, think of a catastrophe. And a catastrophe, like a hurricane or a tornado, everything gets broken down and torn apart. So catabolism includes all of the chemical reactions where we're breaking things down. So say we have a big protein and we start breaking the bonds and we make smaller amino acids. Or we have glycogen, right? This big storage molecule for glucose. and we start breaking bonds and break it down into small little glucose. Any of those reactions where we break things down into smaller compounds, those are concluded in catabolism. So let's look at our choices. Which of the following will we include in the body's catabolism? So break things down. Hydrolysis, yes. Remember hydrolysis reactions? Hydrolysis. So water comes in and lyses things. It breaks bonds, breaks them apart. So yes for hydrolysis. Dehydration synthesis? No, that's the opposite, right? Synthesis, we're making things. That's not catabolism. Decomposition reactions? Yes, hydrolysis is an example of a decomposition reaction. Hey, but think about it. When something decomposes, it breaks down. So yes, those would be catabolic reactions. A and C, yes. None of the above. So the answer is A and C. Both hydrolysis and decomposition reactions are included in the body's catabolism. Next one has to do with hydrolysis, so a little bit more specific regarding hydrolysis. In hydrolysis reactions, compounds react with, so remember, hydro means water, and lysis is to break something, right? To lyse it is to break it apart. So water breaks apart. So in hydrolysis reactions, compounds react with hydrogen causing decomposition? No, right? The name looks like it hydro. Don't get tricked. You know that hydro is referring to water. Compounds react with glucose causing decomposition? No. React with water causing decomposition? Yes. Well, let's keep reading though. Compounds react with carbon causing decomposition? No. Compounds react with water causing synthesis. So the water is right, but the synthesis is not, right? Hydrolysis. So the answer is C. Let's see. Which of the following is false concerning enzymes? So right off the bat, I'm gonna highlight this, false. I wanna know which of these is not true concerning enzymes. Enzymes, remember, are proteins that speed up chemical reactions, right? We've got different enzymes all over the body, and they allow us to make or have chemical reactions really, really quickly. So which of the following is false? Enzymes are proteins? That's true, right? So no, that's not the answer, that is true. The substance the enzyme works on is the substrate. That's true, right? The enzyme goes to the substrate and does something to it. So that's not the answer. Enzymes are catalysts that speed up chemical reactions. That's true, we just said that, so that's not the answer. Enzymes exhibit specificity. Remember, specificity sounds like specific, right? So one enzyme works on one substrate. We have different enzymes because each of them does one specific thing. So that's true. That means E must be the answer, right? But let's look at it. Enzymes are versatile, and one enzyme can catalyze all different types of reactions. No, we just said the opposite of that. We said enzymes are specific. One enzyme works on one specific type of substrate. One enzyme does not go all around the body catalyzing all different types of reactions. Okay, so that is not true. Let's go ahead and pause there, and then I'll upload part 2 with the rest of the questions.